Hi everyone, so in today's video we are going to solve this question. Find the element in a linked list, check whether the element is present in a linked list or not. So we have already solved this question in our previous video, but we did it using iteratively. Okay, we solved the question iteratively using a for or a while loop, but in this problem in this video we have to solve the question using recursion, right? So for example, if this is your linked list and if data is 5, so basically 5 is present, so in this case I'm going to return true, and -3 is not present in our linked list, so I'm going to return false. So how can we solve this question using recursion? So it's very simple. What we'll do, so we'll compare 10 with the data. So for example, I want to search for 5, so I will compare 10 with 5, so match is not there. Then what I will do, so I will call recursion on rest of the linked list, and what recursion will do, so it will check it will iterate through the complete linked list, and recursion will tell me the answer whether 5 is present or not. So recursion will give me the answer true, 5 is present. And similarly for -3, so I will do my work, I will do small calculation, I will compare 10 with -3, they are different. So what I will do, I will call recursion on rest of the linked list, and the recursion will do the work and it will tell me the answer that -3 is not present, so it will return false. Simple. We can just directly write the code. It is a very simple problem. Okay, so let's comment out this part. Let's comment out our old code and we will write the code from fresh, right? Okay, so it is better, let's rename the function. I will return a boolean value, and let's say the name of the function is this time find element. Only the function names are different. So here the name is present, here the name is find element, but the functioning is same. They will do the same work. Okay, so it is very obvious. It will take list as input and it will take the data which we want to search for, right? So we are using recursion. So first of all, what will be the base case? So base case is if head is null. Basically my linked list does not exist. So what will be my answer? My answer will be not present. The given data is basically not present in our linked list. Simple. Now if the data of head, so if head data is equals to the data which we are searching for, then in that case I will return true. Simple. Otherwise what I will do, so I will call the recursion. I will tell recursion, hey recursion, go and find out the answer. So find element, copy this function, find element. What I will do, hey recursion, please give me the answer. Okay, so I will pass head arrow next. I am giving a smaller problem, right? And I have to pass data as well, and that's all. Okay, so only these 3 lines of code and our function will work perfectly fine, right? So let us see, let us dry run our code how it will work. So it's very simple. So for example, if this is my linked list 10, 12, so I am taking very small example, right? So 7 and 2, and let's say the data which I want to search for is 2. Simple. So this is my recursion call stack, right? So this is your main. So main will call on 10. So it is passing head, right? So main is calling on 10. Now check. So 10 null, no. So the data 10 is not equals to 2. So find element and pass the rest of the linked list. So basically pass the next node. So 10 will call on 12, and again we will check this base condition, both are false. So 12 will call on 7, then 7 we will check this condition is false, this condition is false, and 7 will call on basically 2. Okay, so we are calling on 2. Now this time the condition will become true. So this condition is still false because 2 is not equals to null, but see this condition, head data and data, so there is a match. Okay, so this 2 and this 2, they both are same. So if they are same, I am returning true. So 2 will return true to 7. Now 7 is not doing any calculation, right? It is just directly returning the result. So 7 will return true. Similarly 12 will return true, and similarly 10 will return true to main, and that is how it is working. Now if the data is not present, for example if the data is 9, then in that case again, so you have main will call on 10, 10 will call on 12, 12 will call on 7, 7 will call on 2. Now our linked list has been finished, so the next is null. Now 2 will call on null. So 2 is calling on null, and you can see, so null equals null. So this condition becomes true and we will return false. So null will return false. Similarly, see, 2 is not doing anything, it is just directly returning the result. So 2 will return false, 7 will return false, 12 will return false, and finally 10 will return false to main. And we can print in main that the data which you want to search is basically not present, right? So it is that simple. And what will the time and the space complexity? So you can analyze the time complexity is big of n. We have to go through each and every node to compare the data. And for space, you can see, so if the size of the linked list is 4, then there are 4 elements in my stack. So the space is basically big of n. So this is the time and the space complexity of our recursive solution. And what was the space and time complexity for is print solution? So time was big of n because we have to go through each and every node, and the space was constant. Okay, so we were not using any extra space, but for recursion we are using extra space. So which one is better? Iterative one is better. Okay, iterative one solution is better. Okay, so now let us test whether our code is working correctly or not, right? So let's test our code. Find element. So instead of calling is present, let's call find element function, right? Now let's see. So the data is 14, then 52, 78, 12, 3, 6, 9, and then -1. And let's say I want to search for 3. So yes, 3 is present. So found. Yeah, 3 is present. Now let's test it when the data is basically not present. So 1, 2, 3, 5 and 6. So I want to search for 4. So data 4, element 4 is basically not present, so not found. And now let's check when my linked list is basically empty. So -1, and the data I want to search for is, let's say, 8. So 8 not found because my linked list is not containing any element. Okay, so we have discussed the time and the space complexity and find element function. It is time is big of n and space is also big of n. Okay, so time and space both are big of n. Okay, so both are linear. So iterative one solution is better. So if you have any doubt in this find element function, in this recursive function, you can ask me. Okay, thank you.